So let's start. This webinar will explore how to use independent verification and validation techniques to build quality into a project and help deliver an outcome that is useful, relevant, and in alignment with your customers' expectations. We're going to spend some time context setting around project management and the customers who engage your work. We want to understand who you are trying to please with your project, and we'll investigate what customer satisfaction looks like and what it takes to achieve that. And project quality can be difficult to scope as it is often a feel. However, understanding how to match the level of quality to the customer's desire for that quality will be important. So we'll want to talk about ways to do that as well. Then we're going to shift to what is meant by independent and talk about why independence is important in these two areas. And we'll specifically talk about the differences between verification and validation. And finally, we're going to tie it all back together and talk about where in the life cycle of project management these processes occur. I realize that many, if not all of you, are interested in and engaged in the project management methodology. And some of you may have deep subject matter expertise in this. But for those of you that don't, and to also those that do, we just want to level set and put in context what we're going to discuss. So I'd like to start with project management as a discipline and speak to that a little bit. So this discipline emerged in the 1950s and over time has become widely accepted, and it's a proven methodology. So much so that it has driven rigorous definition of standards across many different associations, especially the Project Management Institute, where this course can help you earn those valuable PDUs to retain your certification. No matter which association you align with, throughout all of these standards generating organizations, the single most consistent standard is that around project definition, what makes a project. And that is that it is made up of a temporary set of activities designed to create something unique. Project management as an established discipline means that there are standardized activities that can be followed. When they are followed, we can have a reasonable expectation that we will achieve the outcomes that we've laid out for our project. If we neglect to put these activities into practice, our risk goes up and the probability decreases that we will achieve our desired results. The project management discipline covers all activities across the project lifecycle, from planning to execution to project closure, while all along managing change carefully. And you're going to hear me speak on managing change over and over throughout this presentation, because that is one thing that is often not done well in a project with catastrophic results. Stakeholder management is where we focus our conversation, where I'm going to focus our conversations about our customers, because they are a key stakeholder. And then quality and change management go hand in hand. And so we're going to investigate those processes in relation to measurements and risk management. They're all tightly coupled and interconnected. And if you do it right, the symbiotic relationships between those will really elevate your project outcomes. This is also where the processes associated with independent verification and validation live when you're talking about quality and change. And project lifecycle management is the process that allows us to determine where we are in the project execution within its full life cycle from end to end. Where we are in the life cycle matters in our risk management and also in how we engage with our customer. We will discuss this more at length later, but suffice it to say for now that the earlier in the life cycle a project is, the more closely it is in the research, a research project. then the farther it has to go to achieve its outcomes. And that makes it harder to meet customer expectations, which is why there's so much change that emanates out of research projects. And so many of those research projects do not meet customer expectations. Not only is the project's location in the life cycle a must-know item, we also need to understand the project management methodology or methodologies that are being used on a project. Now, over the decades, the PM methodology has evolved from traditional waterfall-based methods to include highly flexible methods that embrace change and require constant customer interactions. We've even evolved to the point where projects can implement multiple project management methodologies within the one project. In that regard, I will say something like if you are working on a new hardware software combination and the hardware is not going to advance, you're just going to use existing hardware, but you're going to modify your software, then you might use an agile approach for one and a waterfall based method on another. So you can think about these methodologies being used concurrently or both in the same project. And that is fairly new thinking as well. When we dig down into the processes that project management provides to us, we see that they lead us to that all familiar iron triangle of cost, schedule, scope, and quality. And the processes that we will focus on today really sort of live in the areas of, in the process areas of stakeholder management, communications, change, risk management, measurements, and reviews. And within each of those processes are pieces of this that need to be pulled together in order to increase your ability to meet your targets and to satisfy your customer. Now, slightly off topic for this group, but complementary is the systems engineering discipline. Systems engineering gives us strong processes and measurements and reviews, technical risk reduction, and test verification and validation. These processes are found in project management, but the systems engineering discipline provides more structure, templates, and information about when and where to apply the processes. Don't worry if you're unfamiliar with systems engineering. We will be extracting the fundamentals from the systems engineering processes and talking about where they fit in the project management lifecycle. Okay, so with that in mind, these descriptions of the processes that are available to us really set us up well to delve into our next topic, which is about the person or organization that funds our project and the reason our project is in existence, and that is our customers. So who is a customer? Who do we count as a customer? A customer is a key stakeholder who has the need, right? They fund the project, they have influence on the project, they expect something from the project outcomes. In its most basic form, your customer is your key stakeholder and the entity for which you're doing the project. It is the person with the interest or concern. The key stakeholder is a person who is holding a role where they not only define what success looks like, but they're also responsible for validating at the end of the project that the outcomes of the project are meeting their needs, meeting what they want, what they are hoping to get from this. The tricky part with customers is that they may not know what it is they want to ultimately receive from the project. They might have a fuzzy idea of what that looks like. They may even just hand you money and tell you to develop something amazing. If they do that, you have a wonderful opportunity. That doesn't happen very often, but that's always a good place to be. Generally, your customers will have some expectations on how much money you can spend, how long they are willing to wait for that product or service or anything else that you're developing out of the project, and what they get when you're done, what they will actually be provided once all said and done and your project is ended. So if you have any expectation of achieving customer satisfaction, you're going to need to actively manage your customer throughout the entire life cycle of the project. So as a start, let's talk about how you do that. You need to engage your customer as early as possible, and then you need to interact through each phase. And that's as appropriate by the project management methodology being used. For example, if you're using standard waterfall method, you're going to probably gather your requirements at the front, and you might give updates throughout the project, but you're not really interacting or engaging your customer in your day-to-day work. You're just, unless there's a major change that comes up, you're not really going to interact with that. On the other far end of the spectrum, if you're running an agile project, you're probably going to be engaging with your customer on a regular basis. So engaging your customer as early as possible and interacting as appropriate through each phase, that will develop your relationship, but it also will help you, once you understand what your project looks like, it will help you develop your stakeholder register and your management plan and your communications plan that will help you interact with those stakeholders, key stakeholders and customers in the appropriate way. And there are so many different ways that stakeholders, including your customer, may want to engage with the project, that it would be impossible for me to list everything here. But fundamentally, at the beginning of the project, you'll want to, set up a spreadsheet that helps you clarify what your customer's intent is, what is their interest in engaging the project, their level of influence, the level of perceived support, and their preferred communications method. We'll talk about this and build on the spreadsheet thought as we talk further on, that you'll want to build that spreadsheet as you start developing your scope. Now, your stakeholder plan and register documents are all pertinent information that you use to really understand your customer and your key stakeholders, and inclusive of how they prefer to be communicated. Now, this is where we bring in the systems engineering methodology around test verification and validation in order to understand your baseline scope, and to manage change against that, you need to understand the requirements of your customer. So if your customer's requirements are non-existent or vague or extremely high level, that's really okay. You're just going to want to document what they know, and perhaps they know that they want to have an outcome that is, for example, a next generation wind farm, but they have no idea how to decompose that into its more rigorous elements that are design and build ready. One thing is for certain, if you settle for baseline requirements that you cannot control, that you cannot manage control against, that you ultimately will not be able to test or verify performance against, then getting your customer to be satisfied will be near impossible. So the stakeholder plan itself provides the overarching processes that will be used to identify stakeholders, assess their preferred communications, and elicit their requirements, including measures of effectiveness and key performance parameters, which I will share a graph on that concept in a few slides. But don't stress about it if you're not following what I'm talking about here. Okay. Go back and just make sure I've got this here. So when you're, as I mentioned, there's a little bit of there's a spreadsheet here that shows you sort of the top line items that I called out that you'll want to kind of manage and identify. And then the second chart down here kind of gives you an example of each stakeholder. And let's just say the first stakeholder is your customer, and you don't perceive that they're very supportive, but that we're highly interdependent on them, and they really aren't interested in much communication, but you need them to be much more communicative. You can document all of that, and then you would develop your plan around that. So you want them to engage with the project in the right ways based on how you are managing your project with your project management methodology. So your stakeholder plan and stakeholder register, they're pertinent information that you're going to collect information on your customer. We're going to document the preferred communications. We're going to determine what their perspective is on the scope of the project, what we're actually doing. And we're going to really dig down and see if their requirements are vague or high level, or how far down you can actually tease that out. When I do talk about measures of effectiveness, and you're going to see this further on down when we're looking at tables and charts, this is a metric used to measure a current system state, such as, a measure of effectiveness could be how fast something goes, or how long it can go, or how much time it needs to be up and running, or frequency. So that's sort of a measure of effectiveness. How effective is it? And when we talk about key performance parameters, they're capabilities that need to be met for a system to meet its operational goals that are set by the user or the customer. So, for example, debt to equity ratios, or working capital, or current ratio, return on assets, things like that could be key performance parameters. It also could be, in the case of the windmill example, could be the amount of electricity generated. So these are key performance. If you don't meet this, you have not achieved success in your project. So that's super important we're going to come back to those measures, but I just want to kind of summarize that when we're talking about where you capture your customers' intent and requirements and sort of their expectations is going to be in the stakeholder register, and how you plan to address that is going to be in your plan. And it's not just the customer, though. It's all stakeholders, all key stakeholders identified, their desired communications, the project team's desired communications, and all other pertinent information. It's used to develop and execute that plan throughout the entire project. So just to iterate, you should engage your stakeholder management and engage in stakeholder management and start your close work with your customer immediately upon knowing you will be doing the project for them. If not earlier, you probably will have it earlier if you've been developing a proposal for them or with them. And why should you engage in this process? Effectively managing customers and stakeholders is a key component of successful project management, and it really can't be ignored, or it's ignored at your peril. It is an essential activity if you are aiming for customer satisfaction in your project outcomes. It's important to utilize support and mitigate risk to the project associated with lack of support or resistance, conflict, or competing objectives. And it will give you a firm footing on which to manage change, address new requirements from the customer, which we know if you're not running an agile project, new requirements drive schedule impact and cost impact. And it will help you understand what you will need to do to ensure that your customer is satisfied at the end of your project. So let's dig into the statement a little bit more, customer satisfaction. Can there be such a thing? Is it achievable? Let's find out how we can increase our probability of achieving successful outcomes and customer satisfaction. I believe the answer to both of those questions is yes, there is customer satisfaction and it is achievable, but it takes concerted effort and it takes dedication to sticking to the processes. I like to use models that help explain what we see in the world around us. In this case, I built this model to explain what perceived success or perceived failure usually derives from. And typically, I won't say always, but typically, if your customer has a favorable experience with your project and with you, if you have provided as a project outcome something that is deemed useful to that customer, you have surpassed expectations on what the project achieved, and the results were as expected after you have your baseline plus all your accepted changes, then you can anticipate, all else being equal, that your customer will perceive the project as a success. And alternatively, if your customer had an unfavorable experience, if the with either your team or yourself or just the project in general, the project provided outcomes that are not useful to the customer, or your project did not achieve the results as expected, you can be pretty sure your customer will not perceive the project as successful. I think at one point or another, if you're in project management, you've had the situation where you haven't managed change or change has not been managed effectively. You get to the end, you've provided the customer exactly what they said they wanted, but time has marched on, requirements have changed, it hasn't been adapted into the project, and you have a project that is the outcomes are then just set on the shelf and useless and wasted the project in a sense, because what's coming out of the project is not helpful and not going to be used. And that's always sad. You don't want to see that ever happen. How do we apply stakeholder management to customer relationship management? And I will tie all of this into verification and validation. So have some patience. This is all really foundational work that makes verification and validation work effectively. So how do we apply stakeholder management to customer relationship management? Again, we're going to pull in some systems engineering methodology to help us along. And I particularly like to use a requirements verification traceability matrix. The acronym is RVTM, to fully document all customer scope information. It can work in any methodology that you're using, project management methodology. And I'm going to show you a spreadsheet model on this in the next slide or two, so you can get a sense of how you set this up. We will just, what we want to do is focus on your customer's needs, document those, and then plan for communicating throughout the project's life cycle on how you're doing this. Of course, executing to the plan and then managing change and continually updating that. It sounds simple, right? But anyone who has worked with customers knows that this is not simple nor easy. Even getting to a solid set of requirements can be quite difficult. And the requirements verification traceability matrix can really help you hone in and do that. So in order to track quality performance, a requirements verification matrix is created to track the testable, non-ambiguous requirements in clear, simple statements of intent. An RVTM is a spreadsheet that's formatted to capture each requirement as stated by the customer. Each requirement has a specification. It has an intended verification activity that can be used to test and prove that the requirement is being met technically. And then it has validation criteria that has been established by the stakeholders. And your customer. So for example, if you have a requirement, and I like to use the windmill because everybody kind of knows what a windmill looks like. And you have a specification for a new motor, and that new motor speed has got to be between these different parameters. And you're going to verify that with a test to see if it runs within those parameters. And if it does, that verification has been proven, that verification step has proven that technical action has been met, then the customer will come back and validate that that meets their needs. The motor, the engine, the motor is still running at the appropriate, within the appropriate parameters. Those parameters have been adjusted based on change control, and that customer is going to be validating that yes, it is doing that, and it is satisfying their need in the project. So an initial requirements verification and validation matrix provides a target for which test verification and validation activities are recorded and approved, including sign off by the customer when the verification and the validation happens. The documentation required to capture results from testing and verification can vary widely from project to project, depending on the complexity and the life cycle phase of the project. And that's okay. If you're in research and development projects, the amount of times that you're going to do test, verification, and validation, test, verification, and validation is going to be much more often than, again, if you're building a production run of a part that's been made a million times over, you know what you need to make, that's written down, it's documented, you understand there's not a lot of complexity to it, or there is, and you have that firmly embedded in your processes. And then that verification should be in a bounded range, easy to test and easy to validate. Now, in an R&D where you've got a lot of ambiguity, you may not even really know your ranges. You're just setting them, and that can move many times over the course of the projects. So what you want with your RVTM for your project is to understand how you're going to test, verify, and validate those parameters. All right. All right. So if your customer has no defined requirements, which happens often in R&D, then it helps to use natural language to try to obtain a vision of what the customer is aiming for. You can still decompose these over time and develop test verification and validation plans. But what you want the customer to do for you here is to call out what I state as the project North Star. If you can get the customer to describe what this thing that they want will look like in its operations phase in a perfect world, then you can often work back from there. Okay, so in the windmill, right, what they want is a next generation wind farm capability that generates more electricity for less input, less wind. So it takes less wind to generate electricity. So if they can state that, what that looks like in the perfect world, then you can then decompose that back to, well, you're going to need advancements in materials. You're going to need advancements in design of the windmill blades. You're probably going to need advancements in motor design. And maybe the transfer of the electricity from the windmill off into the electric grid. All of these may or may not need research and development. But if you have your North Star, you can begin to develop your RVTM. You can begin to call out where you want to do research and determine for each one of those requirements where you are in the project life cycle phase. Some of these things may need research. You may decide that the base will never change, and you can just use the same base. And therefore, if you need to build more bases, that's a standard waterfall project. Move ahead from there. So getting that North Star identified and documented and confirmed and signed off by the customer is going to be a great, great first start. So take care during the customer and stakeholder analysis to define in conversation with them what how to measure the effectiveness of this. So if you go back to the windmill example, when they say, state of the art, next generation wind farm, what are they measuring that against? What does it mean to them when they say state of the art, future, next generation? What does that mean? Does that mean 100-fold increase in capability? Does it mean 10% decrease in cost to run the facility? Those are going to be absolutely essential measures so that you can prove those measures through test, verification, and validation throughout the project. And then walk through your concept of operations. Walk through use cases or scenario definition. Get them to describe how they envision certain things within each of the requirements. That is really going to help you communicate, develop your key performance parameters. It's going to help you understand where you need to manage change carefully and where change is not going to be a high driver. Be careful to identify with the customer what validation criteria they're going to use. So for example, they say next generation wind farm, 100% increase in output, 10% decrease in cost to run. How are you going to validate me on that? So if I show you this, that all of my verification steps have been complete and it's all within the range, the parameters that you've set, is that sufficient? And get them to commit to that, because sometimes they'll throw a validation step in there, a validation criteria like satisfaction of their users. You have no control over that. You absolutely cannot control that. So if they're going to grade you, validate the project outcomes using that criteria, you're going to have a problem and you're never going to reach satisfaction. So the more you can hone in on how are they going to grade you, the better it's going to be for you and the more success you're going to achieve out of that project. If you have a clear set of measures of effectiveness, key performance indicators and parameters, and validation criteria defined and agreed upon with the customer, your risk is going to be seriously reduced on this project. And you're going to be able to, as long as you continue to change control and communicate, you have a very high probability of getting to that satisfaction at the end of the project. Remember that the project management methodology that you're using or methodologies is going to impact your stakeholder involvement, right? So projects that accept a lot of change out of cycle, they might have low architectural design maturity, they're working at a slower tempo, they have a high degree of user involvement needed, those are going to impact your approach. And the tools are simple. The work that is put into the identification and the analysis of the stakeholders, that's going to be the value added. And the real value of the effort is going to be what you put into it. That is not demonstrated until the end of the project when the key stakeholders effortlessly accept the outcomes of the project, which you want to happen. So I've added in some template material if you want to try this with one of your own projects, which I highly recommend. The RVTM will capture each requirement, who the stakeholder is, or who owns the requirement. If it's a customer, obviously pay careful attention to that. What category it falls in, the verification method, the acceptance criteria, and the validation method. Each requirement needs a unique identifier. And you may document additional information such as key performance indicators, measures of effectiveness, measures of performance. And each requirement needs to have documented its verification status, its validation method, and to have that actually signed off. If this document is carefully managed throughout the life cycle of the project, by the end of the project, sign-off should be simple and straightforward. But I will tell you that this is theory. Theory and actuality, how you live day to day and how you work your projects is going to be much more convoluted, much more complicated than this. But with this really rigorous theory behind you, you can make a lot more progress in reducing risk on your project than if you don't follow this methodology. Okay, of course, this is also highly dependent on your communication plan, success as well, your communication timing, tempo, formality, and transmission needs. You need to agree with this with your customer beforehand, and you need to align that with what you need from them and what they are expecting from the project. Um, don't forget to communicate whenever change is evaluated and accepted. That's essential. And regardless of the method you use, change requires careful and constant communications to all your stakeholders, including your customer, your prime objective there. We've spoken about project structure, who customers are, why it's important that they are satisfied with the project outcomes. We've discussed methods to capture their thinking on what success is and how to document that throughout the project. Now we need to talk about quality, as this is an attribute really that I mentioned before that's often hard to define, but essential to the satisfaction of the customer. It is also one of the most important attributes to test, verify, and validate. And quality is most effectively evaluated by an independent third party, not necessarily the project participants, the project team, or the customer. And let's dig into this a bit. Here we go. Here we go. We can think of quality on many fronts. Quality can be the perception of getting value, getting what we want, getting the experience we want. And when we're trying to form a perception of quality, we do so with solid project baselines and change management, risk management, mitigation and risk reduction, transparency, and also invited input to the processes and the project itself. So if we want to have a high level of perceived quality in our project outcomes, we start with solid change control. And ultimately, quality outcomes start with well-formed and agreed upon baseline requirements. And then we've added in well-formed and agreed upon change requests. And this will equal quality project outcomes and customer satisfaction in theory, but also in practice from my experience. I have run many, many projects with this methodology to very good success, and many satisfied customers. So it does actually work. And I think where the most projects trip up is in not managing risk and not managing change effectively. Keep in mind, too, that project volatility can drive the perception of quality. So stability or a low level of change, a low number of required iterations on each requirement, and a set of known expected outcomes from a project requires a low level of creativity and can be much easier to help form perceptions of quality around. Conversely, high levels of change around unknown requirements and many iterations to get things right can lead to a perception of a lack of quality, potentially leading to a lack of satisfaction by the customer. Depending on where it is in the life cycle, that's easy or hard to do, to get that stability and to manage change. The closer it is to basic research, the harder it is to get that stability. You're going to have, as you go towards basic research, infinity numbers of changes, right? Could be completely unknown outcomes, requires an intense amount of creativity, and your iterations, you just expect them to be nonstop. And conversely, with operations, when you're doing a production run on something, you don't need a lot of creativity. You just need to get it done. It's not going to have a lot of iterations, it's not going to have change expected, and you know what you want to get out of that. So, depending also on the life cycle phase of the project, quality can be built in through the strategic application of reviews. Throughout the system lifecycle, quality is controlled across all process areas in many ways. The two methods that are identified as essential are the use of audits and gate reviews because they have been shown to be highly effective in assuring quality. And formality requirements from the customer, from other key stakeholders, and from the organization will drive your tailoring options. And I have another presentation, another webinar on tailoring. If you'd like to look that up, I would love to have you review that as well. The types of reviews and tempo of reviews typically track from the formality requirements and also are driven by the lifecycle phase, the approach, and the level of control desired. So generally, if formal reviews are required, that speaks to a level of rigor that's expected for successful project execution, and following standard processes for the reviews is therefore warranted. There will be virtual and other reviews that you can do to look at new processes and procedures, but make sure that your customer is in agreement of what's needed and how they'll be executed, and which kinds of reviews you need. Boy, there's so many different kinds. I won't spend a lot of time on these right now, but I will just say there are certain reviews that are going to be really critical as far as getting your customers buy-in and agreement that they're getting what they need throughout the project. There might be things such as a PDR, which is a preliminary design review, which confirms that the system is consistent with the specifications. The risks have been formally addressed and the system can move forward in development. There's also a CDR, a critical design review, which evaluates the system design documentation, known as the product baseline, and ensures that it correctly is represented in the draft production baseline that will be produced, and that is going to meet the needs of the customer. A production readiness review, a PRR, is also extremely important for some customers. So know what reviews they need. Some of these will be contractually required. Some will be just things that you can do to make the customer feel comfortable and that they are, being heard. Another very common set of reviews are the technical readiness reviews, often used in larger organizations where you're building major systems or system of systems. And these technical readiness reviews start from the lowest level, which is where you have you're moving up the chain just like you would, and looking at the technical readiness level 1, which is your basic research, all the way up to 9 when it is ready to go into space or be implemented and operational. So know what is required by your customer and put those reviews in process. It won't hurt you to do that. It will help you tremendously. Controlled progression can be applied in combination with reviews by establishing the specific gates that the organization is comfortable with identifying and for which the project must pass. And each time this is done, the customer's perception of the quality of the project and the anticipated outcomes can be anticipated to be more stable. I'm not going to say always, but I'm going to say often. Okay. And depending again on the life cycle of the project, your baselines could be simple or highly complex, incorporating earned value methods and technical risk reduction strategies. Remember, the project baselines are the key measurement areas that are important to the project and demonstrate a starting area for which all progress and change are vetted. These can be lightweight, or they can be rigorous, such as with the use of full earned value management and technical performance measures. At a minimum, though, having established baselines and cost, schedule, and scope are essential. And quality And those come out in your verification and validation measures. These must not be changed, right, without careful evaluation of the potential impacts, unless, of course, you are one of those lucky few where cost, budget, and schedule are no consequence, and then lucky you don't have to worry about that. Careful alignment of methods to needs, making sure only the processes that are really needed to drive quality are implemented, will help ensure the project's success and the customer's perspective that the project was a success. I want to focus now on risk as a key component of quality. Quality controls will take the form of test, verification, and validation. These three activities have different objectives, but work together to ensure that progress towards outcomes is controlled. The level of effort and rigor that are put into each of these activities can widely vary from project to project. However, don't ever ignore them. Both the management of risk and risk reduction, which are two methods used within project management and systems engineering, are directly related to quality assurance. How much risk we're willing to take on can be a byproduct of our organizational perspective on risk, your customer's perspective on risk, and your own perspective. If your organization supports experimentation and risk-taking, for example, then more risk can be assumed in the project. For example, you may not need to be as rigorous in the definition of your requirements, because if you have a lot of change that impacts schedule or budget, that's acceptable. Developing a risk register and managing that actively throughout the project will provide more expected outcomes and potentially higher quality as well. And knowing what the risks are for a project and discussing those risks with the customer regularly and inviting them into the discussions of the risks will foster trust and ultimately lead to customer satisfaction in the project outcomes. Whenever a quality control activity identifies shortcomings, these become risk items. The project manager and the system engineer must work to resolve the issue before progressing. Resolution is through standard risk management for the project and can result in different mitigation strategies. If changes are required to address the impact through the revision of scope, schedule, or budget, the change control process is engaged. In this way, these processes are tightly integrated. If you do one without the next, you're going to miss your targets. The process of technical risk reduction provides a way to track each requirement against a test and an evaluation plan. Testing provides the opportunity to verify the performance of a particular activity against the expected performance. Test controls generally are in place to ensure that both real and simulated components, parts, subsystems, the system being tested, any of that meet the expected performance specifications and tolerance levels and contain the appropriate attributes within controlled conditions. So anything you do in this area of technical risk reduction is going to reflect and be documented on your RVTM, your Requirements Verification Traceability Matrix. Depending on the size of your project, again, the rigor applied to technical risk reduction can vary. Some projects use a tolerance graph like this to demonstrate an expected predicted evolution of their technological capability that draws directly off the RVTM. By showing this in a chart like this at every major customer-related review, the upper and lower tolerances, the test results against the expected evolution, this can build confidence, trust, and satisfaction with the customer. I love this, using this graph. It's very helpful. Now let's put in context what we've explored so far, okay? We've spoken about project structure, who customers are, why it's important that they are satisfied with the project outcomes. We discussed methods to capture the thinking on what success is. We talked about how to document that and continue documenting that throughout the project. We've reviewed how we can think about quality, an attribute that is often hard to define, but essential to the satisfaction of the customer. And we've talked about how it plays in the processes of test and verification. As mentioned earlier, quality is most effectively evaluated by an independent third party, not the project team, not the customer. So let's speak for a moment about independence in verification and validation. Independent verification and validation refers to the process that is used for assessing without influence, without control, or determination by the project team or other key stakeholders that the project outcomes meet the requirements and specification and that it fulfills its intended purpose. You could imagine that a project team assessing their successes or the customer or other stakeholders assessing the success of the project without an independent viewpoint could skew the results. The process includes two very key activities, verification and validation. So we've reviewed the interactions between test and verification. And now I want to spend a little bit of time further defining verification and then validation. And I think you'll see and agree that these two highly interrelated processes tie directly into customer satisfaction, and it is important to get an independent assessment of whether or not they met the requirements. Now, that independent assessor should be a subject matter expert. It can be somebody internal to your organization. It can be an external volunteer who comes in and assesses it. It can be one, it can be a team. It depends on your project, frankly, and your own assessment in working with the customer. Work that together. Who should be an independent verifier and validator? So verification is a quantitative, objective, evidence-based measure. Okay. Verification is the act of confirming that the project outcomes technically meet the requirements. Is the accuracy of performance we're wanting to understand. Verification controls ensure that through various methods, modeling, simulation, inspection, audit, physical examination, what you're looking for is that the controls are in place and that there is reliable evidence supporting the performance that is specified and that the performance is repeatable and stable. When we talk about validation, this is on the receiving side of the project. Validation is the final step in your project that the customer is responsible for. It is subjective, it's qualitative, it's conjecture-based, and that's the type of indicator it is. It is the step that determines how satisfied your customer is, reflects how satisfied your customer is with your project outcomes. Validation is the act of confirming that the project outcomes meet the needs of the customer and other key stakeholders, that the performance is as expected and desired. Validation controls ensure through inspection that the stakeholder concurs that the performance demonstrated in the verification processes are suitable and are satisfied with the final outcomes, and that the project outcomes are going to meet their needs or meet their needs. And I like this little model. You've seen it all the way through. And I, highly recommend you use this because many people don't understand how things connect, how the dots are connected, that the customer sets the measure of effectiveness. And this is what they're validating, the measures of effectiveness. But the measures of effectiveness drive for the project team what they define as the key performance parameters, the measures of performance, technical performance measures and indicators, and that they define the test and verification. and that the test and verification feed into the validation and reflect what should be a complete alignment back to the measures of effectiveness. Okay, so now it's time to sort of wind it all together and describe where all of these processes lie within the project lifecycle. Suffice it to say that throughout all project life cycles, from earliest research to production projects, working closely with your customer as you engage in these processes will really provide the highest probability that you're going to do what we've been talking about this whole time, achieve customer satisfaction and assure project quality by using independent verification and validation as essential processes throughout your project. I can, you know, I could give you so many examples of where this series of processes really made a huge difference in how project outcomes were accepted by customers and how satisfied they were. And a satisfied customer will come back for more project work with you and your team. So that concludes my presentation.
Lory, we thank you so much for your time and for presenting.
Thank you so much. Have a great day.
Thanks, everyone.